Okay, 2.4, deductive reasoning. The objective, students will be able to use the law of detachments and the law of syllogism by completing problems as taught. Okay, so a couple terms here. Inductive reasoning, this is what we did in 2.1, but this is drawing a conclusion based on an observed pattern. So we look at a pattern, and then we are able to draw a conclusion from it. Deductive reasoning is a little bit different. This is reasoning from given information, so given info, to a conclusion. And if any of you guys are Sherlock Holmes fans, this is what he does. In fact, I'm pretty sure he has some famous quote that says, deductive reasoning, you know, like he says it a lot about Dear Watson, deductive reasoning. So anyway, something he uses a lot because he'll look at scenarios and he'll say, hey, I can tell this, this, and this, therefore I know that so-and-so was the killer with the butter knife. Who knows what he does, but basically he's gonna look at information in a scenario and be able to make a conclusion from it. So let's move on. Let's do a couple examples. Example number 1. The average person knows that if you do not charge your cell phone battery and it dies, it will not turn on. Use deductive reasoning to draw conclusions for the following 2 examples. A. Thinking back over the last few days, you realize you did not charge your cell phone and your battery is dead. What can you conclude? Well, we can conclude that it won't turn on, right? We know that just using deductive reasoning. Hey, I didn't charge it, battery's dead. Oh, you know what? It's not even going to turn on. I don't even have to try it. I know that's what will happen. I'll probably try it anyway because I want my phone to turn on, but it won't work. B, you go to make a call on your cell phone to find that it won't turn on. Can you conclude that the cell phone has a dead battery? Well, think about that. Just because the phone won't turn on doesn't necessarily mean that it's because the battery is dead. So we would just say not necessarily, right? Because there is, I don't even know if I'm spelling necessarily right. Not necessarily because there could be other reasons why the phone won't turn on, right? Like the phone could just be broken. If you just ran over your phone, that could be why it won't turn on. There could be lots of different reasons why it's not going to turn on. All right, and just in general, we're going to start using this notation. We're going to use P to talk about our hypothesis and Q to talk about our conclusion. So when we say an if-then statement, if such and such hypothesis, then conclusion, we're going to shorthand it by saying P, then Q. If P, then Q. That's what this guy means right here. So we can actually write that. If P, then Q. And P being some scenario, some hypothesis, and Q being some scenario or some conclusion. And I know that I said hypothesis in here, but that was a typo. So that should be an H. It should be hypothesis. Sorry. All right, let's go on to an example about law of detachment. Law of detachment, this is when we take a general conditional statement. So some statement that's very, very general. This is important. Very general statement. And then we, this is a conditional statement, and its hypothesis, wait, let's back that up. If a general conditional statement and its hypothesis are both true, then its specific conclusion must be true. So it goes from general to specific. This is really important, that it goes from general to specific. So the proper form should look like this. If P, then Q, and then they give us a specific example of P. This would be our specific P. Therefore, we can assume Q. And these three little dots like that, like I just drew, that actually means therefore, if you want to write that down if I haven't shown you that yet. So we could say specific P, therefore specific Q. Now let me show you what I mean by that, because that could be a little confusing. So let's talk about this. If a baseball player is a pitcher, then that player should not pitch a complete game 2 days in a row. Barry Zito is a pitcher. On Monday, he pitched a complete game. What can you conclude? Okay, well, this statement here, this if a baseball player is a pitcher, then that player should not pitch a complete game 2 days in a row. That is my general statement. That is very, very general, I'm going to write this. You know, that's a little bit hard to see. Let me change that, see if I can write over it. Yeah, it's still not that easy to see, but you get the idea. That is our general statement. And then this whole thing about Barry Zito, that is our specific example. Barry Zito is a pitcher. So, therefore, he applies to this general statement above, right? He is a part of this general statement. It applies to him. So, what can we conclude? Well, we can conclude that since Barry Zito is a pitcher, that he should not pitch 2 days in a row, right? But it says he pitched on Monday, so we should say he should not pitch on Tuesday. And that's it. That's what we can conclude. So we took this general statement about a baseball player that should not pitch a complete game 2 days in a row, and then we applied it to this specific scenario, Barry Zito, and gave him even a specific time. So this is very specific, and the above statement, the original, is very general. So we go from general to specific. All right. All right, so let's try this a little bit more, be a little bit more proficient in how we handle this. So here's another example. Example number 3. It says given. If someone is deaf, then she has limited hearing. This should be he or she, but our specific example does happen to be a she. So let's just put a little he/she has limited hearing. Again, this is my general statement here, okay? So this underlined here, this is my general. But now let's go to specific. Heather is deaf. Okay, so in general, if someone is deaf, then he or she has limited hearing, and now we have a specific person who is deaf. Can we make a conclusion? Yeah, we can, but let's not go there quite yet. Let's fill in the information. So let me give another color. My P part, remember the P is the hypothesis, so I would write the P part is someone is deaf. And then he or she, this is my conclusion, my Q part, he or she has limited hearing. All right, so there's the P, there's the Q. And so in general, the law of detachment should look like this. It should say, hey, if P, then Q, given a general P, then Q, and then you're given P, a specific example of P, and therefore you can conclude Q. Okay, so like in the baseball, we were told, hey, you know, if someone's a baseball player and they're a pitcher and then they should not pitch 2 days in a row. Well, my specific was, hey, Barry Zito, he's a pitcher and he pitched on Monday. Well, therefore, Q, he should not pitch the next day or Tuesday. So let's write down what we have. Well, we do have an if P then Q, right? Because we have up here, if someone is deaf, then she has limited hearing. There's my general statement. And I do have a P as well. Look, I'm given a specific P here with Heather is deaf. Heather is deaf, P. Okay, well, therefore, we can conclude our Q, which would be that Heather has limited hearing. All right. There we go. So it needs to look like this. If P, then Q, P, therefore Q. I know that's a little confusing because you got these P's and these Q's. But remember, these are just kind of like variables that we can substitute stuff in for. So we're going to substitute in for P, that someone is deaf. We're going to substitute in for Q, that he or she has limited hearing. And then this is my specific example, P, which is Heather is deaf, and therefore Heather has limited hearing. That's all it means. So let's give it a try on this next one. It says, if a road is icy, then driving conditions are hazardous. Driving conditions are hazardous. Okay, well, let's write what we have. A road is icy would be my hypothesis. And driving conditions are hazardous. That would be my conclusion. And let's see, the correct form says, like we said before, if P, then Q, specific P, therefore specific Q. Okay, well, the current form. We do have an if P then Q. Good. But then they just say driving conditions are hazardous, right? Well, that's not part of my P. That's part of my Q. So I would say I have a Q. Well, that does not follow the same pattern as above, right? I need to have a P right here, not a Q. So I can't conclude anything else. So a conclusion? No conclusion. I can't conclude anything. And if you think about it, that makes sense, right? So if we were to go back here, up here, if a road is icy, then driving conditions are hazardous. True. But if I was just told, hey, driving conditions are actually hazardous right now, that's a specific example. You go outside, driving conditions are hazardous. That does not necessarily mean that the road is icy. I mean, that could mean, hey, an oil truck's, tipped over and there's oil all over the roads out there or all over the freeway, and that would make conditions hazardous, but it would have nothing to do with the road being icy. So it has to follow this form. If P, then Q, specific P, therefore specific Q. And it did not follow that form, therefore no conclusions. All right, almost through this. Let's keep going. Law of syllogism. Law of syllogism. This one says that if two conditionals are true, so two if-then statements are true, and they have some aspect in common, then they can be linked. And here is how they are linked, right? If P, then Q. If Q, then R. Therefore, we can just skip the middleman and just go straight if P, then R. That's why we have it right there, if P, then R. So it takes out the middleman. Right? That's what we can do here. So let's take a look. We're going to use the law of syllogism to draw a conclusion, if possible. If not, we'll explain why we can't draw a conclusion. So let's look and see what our P, Q, and R are, because now we need to have all three of those. And we have if a number ends in 0, then it is divisible by 10. Well, since this is my first hypothesis, I'm going to call this P. And this is then is divisible by 10. I'm going to call that my Q. And look, it's right here again, if a number is divisible by 10. So there's my Q again. And then it is divisible by 5. That's my R. Okay, so let's fill all that in. A number ends in 0. So my P. Q is it is divisible by 10. And R is it is divisible by 5. Okay, well, the correct form says, right, that if P then Q, and if Q then R, therefore P then R. Well, let's see, is that what we have? If a number ends in 0, then is divisible by 10. Sure, we do. We have an if P then Q. And right below it, I have if a number is divisible by 10, then is divisible by R. Yeah, there's my Q again, and there's my R. So I also have if Q, then R. Therefore, those are supposed to be dots. Let's make it a little bit bigger. Therefore, P, then R. So our conclusion is if a number ends in 0, then it is divisible by 5. And we can skip this middleman, right? We don't even need that statement anymore. That's what it means to use the law of syllogism. It has two linked statements. So what I want you to do right now, I want you to just kind of think of an example that uses the law of syllogism. Maybe try and think of your own example. Here's one for my class, okay? And also try and think of a law of detachment too, if you can. But here's one of my class for law of syllogism. If you're in Mr. Rowe's class, then you go to Buckingham. If you go to Buckingham, then you are a knight. Well, we can skip the middleman there, and we can say, hey, if you were in Mr. Rowe's class, then you are a knight. We don't need that statement about going to Buckingham in the middle. And I forgot to do this earlier, probably should have done it earlier, but up here, it said think of an example using a law of detachment. And I wanted to give you guys a law of attachment example as well. Try and think of one on your own, but here's another one. I said at the beginning of the year that if you don't put your name on your paper, it goes in the fix-it box. So I could say, hey, if you don't put your name on your paper, it will go in the fix-it box. Then it will go in the fix-it box. Well, there's my general statement. Now let's give it a specific example. Jairus did not put his name on his paper, So what can we conclude? We can conclude that Jairus' paper is now in the fix-it box, right? Now, Jairus didn't really do that, but that's what we can conclude. So there's 2 examples. Try and come up with some of your own. And yeah, enjoy.